little bit less populated than the last time we were at it here, but that's okay. We will get started tonight. I'm Dustin. Maybe you guys have emailed me or saw my name in some of the contact info. This is the Detroit Area BIM User Group. This is Rossetti, and Ramon from Rossetti is going to be presenting tonight, as well as Jason Hassel from Imagine Technologies. He'll be up right after me to give some updates on the things Autodesk is doing. And from there, Ramon is going to talk about Green Building Studio and some really interesting energy analysis, design optimization kind of ideas. So that's the plan for tonight. We are streaming live on the internet, so keep it PG or low rated, everybody. Just kidding. And the video will be posted today on our website, hopefully sometime in the not too distant future as well. So that's our plan for tonight. I'm going to have to excuse myself a little early, so thank you everybody for coming, and feel free to share it with your coworkers. And if you need anything, Sandy is the host, and she can help you all with whatever you need. So that's our plan. On that note, I'm going to give it away to Jason. And Jason, can you hand up your one? Sounds good. So if I understand over here in terms of volume? Yeah, the microphone's right here. Got it. That's it. So good evening, everyone. My name is Jason Hassel from Imagine Technologies, a RAND worldwide company. A couple of updates here for the group. The first is regarding Autodesk University. Many of you are familiar with Autodesk University. It's the world's largest conference for Autodesk software users. This year it's being hosted December 1st through the 3rd at the Venetian Hotel in Las Vegas. In terms of costs for attending Autodesk University, the passes currently are $16.75 from now until September 24th. Autodesk plans to increase the price to $18.75 on September 25th, and then there's a final price increase on October 19th of $21.75. So it's the early bird registration cost. If you're considering going to Autodesk University, I recommend that you check that out before September 24th. So Autodesk made a pretty significant announcement from our last user group. On February 1st, 2016, Autodesk is going to stop selling individual products in terms of perpetual licenses. So these are the licenses that most of us use today, perpetual. So things like AutoCAD, Revit architecture, Civil 3D, those individual products, not the suites, but the individual ones, will be available as desktop subscription only, which are essentially pay-as-you-go licensing. So that's a big change, February 1st, 2016.
When you say individual, that means not a company license? Or
an individual as in a non-suite license, so like vanilla AutoCAD, like an AutoCAD architecture, Civil 3D, or a Revit architecture, those will become desktop subscription only after February 1st. Okay? Suites will still be available as perpetual licensing after that date. So,
what about the leasing? The leasing system, all right?
It's desktop subscription is a pay-as-you-go rental model. Yeah. So that's currently in place now for all licensing. And actually, I have this opportunity. So, with a raise of hands, do you guys want me to cover maybe the next user group an in-depth look at desktop subscription licensing versus perpetual, and kind of cost comparison, functionality? Do you guys want to see something like that, or just kind of bits and pieces that we go over?
Doesn't matter. The last time I looked, Autodesk had something on their site that kind of said, well, you bought the license in 3 years, this much, but if you rent it every year, you're saving $1,000 or something like that.
Exactly, yeah. And there's some, the way it's deployed, the way it's used by the end user and managed by IT professionals is a little different.
Yeah.
So,
I should do that, Jason. That'd be good. All right. And actually, if you want to have any like diagrams or slides or info like that,
okay,
email it to me. We'll actually do a proper PowerPoint next time.
Sounds good. I got it. Yeah.
And one thing would be nice to kind of show is when you lease per year, you get the 2016, 2018. A lot of problems that I had when I moved to 2016, the client is still in 2013.
Sure.
And it's not backwards compatible. But if everybody got on the leasing system, every year, everybody just jumps to the new system, everybody's on the same compatibility.
Yep.
And it just makes you save money because you're leasing it per year. It just makes a better product by leasing it.
Yeah. Autodesk has made some adjustments in terms of accessing the current version and the ability to use previous versions, especially if you've owned the technology for quite some time and legitimately own that previous version. You can continue to use it as long as you don't install newer versions of the software.
So they provide that flexibility through subscription. It's an entitlement, and we can cover that as well in terms of being able to use previous versions.
Okay.
And so if you have old projects, you use previous versions of the product legitimately, legally, I should say, through the subscription program.
Even for like a software like Rigid, like if I'm on 2016, I can't work with them in 2014.
Well, workflow-wise, that's how web operates. But in terms of accessing the previous version license, to be able to work with somebody in a previous version,
Oh, I see what you're saying. I can go back.
you can use a previous version license
Image.
to collaborate.
It did.
Now, is that something where I still need to contact you because we still do have this one lingering Revit 20 lesson project?
Sure.
So, or is that something that I can download myself now on the accounts? So we still go through our reseller.
Yes.
Fantastic.
Partners. Yep. So network licensing is a little different. You get the current version and 3 versions back automatically in the license file. So that's pretty flexible as well.
Yeah, we are working on a subscription based on, I wrote that in, we do keep like a couple of back versions just because we've got projects that are still back in those editions, and they don't feel like upgrading it because everybody's still on that older version.
Yeah, and in that example where you legitimately own that, you've owned that older version back in the day, 11 or 12, and have a legitimate serial number, that really makes it a little bit easier for me to create a license file for you, and then just paste it to your new one and get them applied. But for folks that didn't own it back then, it's a little bit different. It's a little bit different.
Laptop 2013, laptop 2014, laptop 2016. That's how I go back. It's not working now. I'll go backwards.
Cool, good questions, thank you. So this one's pretty interesting. In light of this evening's presentation, there's many people didn't know this, but Autodesk actually offers continuing education credits. It's on demand, it's online, on demand, free of charge, in terms of earning AIA learning units for GBCI lead hours. So there's 7 courses offered in high performance building design. All are pre-approved for AIA learning units and the GBCI lead hours. There's 6 courses in simulation CFD for building design and ABC applications pre-approved for GBCI lead hours. Each course requires approximately 3 to 5 hours to complete, and the CPUs provided vary from course to course. So these are available to all of you now. In addition, there's 13 individual courses. Autodesk is offering a free building performance analysis certificate, or BPAC program, which includes 7 course modules and is pre-approved for 28 AIA and GBCI continuing education units. So if you need information on that, I can forward that to Dustin. We can pass it to the group.
Can you send it to me and then I'll put it on the AIA Training app website?
Absolutely.
You can include it in e-blast sent out.
Okay. Yes, great resource. Free of charge.
I recommend the course. I've taken the course. And it's nice because they give you the bookwork first, teach you about high performance, then after you get with the bookwork, they kind of say, okay, this is how you use Revit, this is how you use CFD, this is how you use this, and then teach you how to use the software that goes out with the bookwork. So it's worth it.
Cool.
Taking back.
It's a great point. Thank you.
Let me put it just a second. On the same kind of theme, the state of Michigan is now requiring engineers to track professional development hours as well. So if you have engineers at your office, tell them that these meetings will be good for at least 1 or 2 hours of professional development with each debug meeting. So we're having print certificates for that. Just go ahead and write that out in the sign-in sheet. And so they don't have to formally submit it, but they have to retain records in case of the audit for professional development. So yeah, all the engineers go there, they have a greater interest in joining us now.
Excellent. Thank you, Dustin. Another announcement in terms of resources available to the group. There's a webcast coming up for Autodesk in line with our building performance analysis at the conceptual level. It's on May 21st at 2 o'clock Eastern Time. It's basically Autodesk is coining this to design continuity, building performance analysis throughout the design process. It's a long title for the webcast. So essentially there's 4 goals of this webcast: determine how Autodesk BIM workflows support integrated analysis, demonstrate the ease and speed at which you perform analysis, visualize consistent and configurable analysis results, learn how to use analysis results to guide your design decisions. I'll forward a link to you, Chris. You can share it with the rest of the group in terms of this webcast. That's on May 21st in line with tonight's subjects. That'll be tomorrow. Yeah. It's coming up quick. So Autodesk released a new product. It's called Revit Collaboration Suite. It is a desktop subscription only. It's not available in perpetual, so it's a rental pay-as-you-go model. This is it's Revit, one box, which is AVP structural, architectural, all-in-one, AutoCAD, and then 360 Team in terms of collaboration workspace for project stakeholders, project participants. So that's a pay-as-you-go only license type. It just came out, it's brand new. And it differs from Building Design Suite Premium. It doesn't have maps, doesn't have maps or simulate for collaboration. But in terms of having auto E360 Team, it does allow collaborative workspace for folks to collaborate on projects. So that's a brand new product. It's called Revit Collaboration Suite. How much is that per month? Let's see. It's on the price of it. It's on the website as well, I believe. Oh, that's pretty reasonable. Yeah, it's not bad.
And before it does, I mean, you get to the collaboration and you have your work on the project. Let's say it's a weekend, you're at home on a Saturday, you start working on it, you can log in and start working on the model on a Saturday.
Yeah. Anywhere, anytime, right?
Anytime, anywhere, you don't have to be in your office.
I'll try that again.
You know, I can be a person sometimes, you know, on Saturday, and Sunday. You don't have a laptop, you do it on shop. Or if you're client, you decide, you just pull the model right out.
Absolutely, yeah.
So we're still working on it.
Yeah, for sure. That's a good point. Thank you. There's a number of promotions going on right now. I don't want to go through all of them. Roughly 6. This is a great opportunity to have existing individual licenses like Revit Architecture or AutoCAD or something like that. You go to a suite. There's online. This is a rebate promotion. So it's after the sale. You go online, show your proof of purchase, you get a rebate. There's a number of them. So ranging from a couple $100 up to $1,500. So it's pretty good promotions going on right now. A number of them. If you have questions, let me know. 2 quick announcements here specific to management. I'll round it up before handing it off. Imaginet recently announced our enhanced e-learning offering. So as you may know, Ascent is our curriculum division. We are the official courseware providers for Autodesk technology, ProE, PTC, BESU systems as well. But in terms of our award-winning curriculum, we announced a partnership with 4D Technologies, who provides CAD learning. It's called their product. They are the leading provider of video-based training, enhanced video training. So we announced that partnership, and that integration has already occurred in terms of our e-learning offering to bring our customers the ultimate e-learning, which is the official training curriculum coupled with the industry's leading enhanced video tutorials as well, video training, not tutorials, training. So it's ultimate in terms of, we understand that people learn different ways, and so this is a great resource for folks in terms of the e-learning offering. So we don't, e-learning is not meant to replace professional training. It's great for ongoing learning and honing of your skills to keep people's skills fresh. So that's a very new offering. The other one is a blended learning offering. Many universities offer this style of learning. It's been around for years. Unheard of in the CAD industry, though, in terms of an instructor-led piece where you meet with the instructor at the beginning, break out, you establish the goals, expectations for the following week. The student would then have access to e-learning, access to our e-learning for self-paced e-learning throughout that next time. They circle back, meet with the instructor again to review benchmarks, establish goals for the next week. And this goes on for a series of time until it's done. So this reduces the amount of time that staff is out of the office because we know that people can't get 4 or 5 days in a row on the office for training. So this blended learning offering allows folks the ability to interact with the professional instructor. There's a self-paced portion of it, to learn as you go while you have time, and then come back and meet with that instructor over a series of engagements. So this is what we call blended learning. It's brand new, and it's very exciting. So it's just a new offering in terms of training. Well, that's really it. Is there any other questions? If you have questions, let me know. I'll follow up with that information to you, Chris. You can send out to the group.
I've got two.
Okay.
One is Format Pro, because I know that Format Pro is just rolled out, and then Dynamo Studio.
Yes.
We talk about this one.
No, I actually, I know that the 360 offering just came out just recently, and is available as a cloud subscription. Before standalone products, now they're cloud subscriptions, pay-as-you-go models. That's what I'm prepared to talk about this evening.
Okay.
Right.
Yep, I was looking more at like mobile technology, and I know that there was a here on that there was a form that Dynamo was somewhere.
Well, that's probably a good subject, in terms of the update to review that. So, yeah, so I'll hand it over to you. Thank you.
Well, thanks very much. My name is Ramon Cordes. I'm here with Rodetti. I'm a senior technical designer, and I'm going to talk about Green Building Studio, and I'd like to say that I'm not 100% pro at this. I started working on this less than a year now, along with like Dynamo, which is what I'm also going to show you. So I'm just going to show you some of the stuff that I've been finding out that's been very interesting with us with Dynamo, and because it's just kind of like rolled out, I know made available through Architecture Revit 2014. Once we got our 360 Autodesk subscription in, they analyzed menu started popping up tools that we can use, and that's kind of what we started using it. But before I get started, to give an example, I just want to go in and talk about what Green Building Studio is, to define what it is. There's like a lot of misconceptions of what it can and what it can't do, and then go through some of the concepts in workflow and what to expect out of using the tool. So if there's anything that I get wrong, or if anybody has had any experience with using it, I can add a little bit more. I very much appreciate it. Charles?
Yeah, I've used Green Building Studio since it first came out, so I've used it for a bit to use.
Oh, very
I've watched it change over years.
Yeah, because the first time I've seen it was in Ecotech, and I was dying to use it, but we could never get a company to fully back it, to go in and get that tool set into the workflow and working with Revit. But now that Autodesk has been rolling it out with it, we had the opportunity to start using it, especially when Masari was rolled out. That's when we started seeing what it could possibly do. So anything that you can add, Charles, to any of my stuff, I very much appreciate it. So Green Building Studio, what is it? So as it was mentioned, it's like it's available as an exclusive subscription only to subscription customers, meaning that you do need to have an Autodesk 360 account to use it, to access the tools in the cloud. You can log in at 360.autodesk.com. And because Autodesk is going into a subscription service system, delivery system, you automatically get a 360autodesk.com subscription when you get into that mode of using the software. You can also be accessed within other Revit programs. As mentioned before, I first got instruction for the Green Building Studio toolset through Masari, which was made as an open beta, and which is, I guess, is going to die in this month, May. The support for it is going to go away. But my understanding, everything that was learned during Masari was ported over to Format. Supports import of GBXML format, meaning that when you have Green Building Studio, one of the things that it will create is a universal green building extended model language format, which you can use for other programs to upload to do more analysis or equivalent analysis. Cloud computing capacity for rapid analysis, meaning that the overhead for your computer is no longer a drawback to running software, because it is very exhaustive and it's running for computation. So it takes all the power of the cloud it takes it away from your desktop, meaning that once you put the buttons through your analysis, you can go ahead and do other things with Revit and let this automatically run in the cloud to create the report you're looking for. And this is just done to give you a little message, and then you can click on it and then download it for your preview and review. And also, once you have it up in the cloud, you can also use it and share it with other colleagues or consultants or team members to further develop more detailed model. Compare multiple projects, meaning that if you have a file created there as a benchmark, you can look at other reports and compare and contrast one situation to the next. And then one of the things that it can it'll give you a readout on is energy use intensity. It's very important. We'll get onto that later on. Annual energy consumption and annual energy costs. These are general information that you typically gravitate to when you're doing the energy analysis early on in the conceptual stages of the project. And as I mentioned, it's a cloud-based energy analysis service for the AEC industry. You can use it for both new and existing projects. It will do whole building analysis, meaning that it not only does the energy envelope, but also water usage and solar, and also potential also. So it's got a lot of broad aspects for what you can look at, and you can work towards carbon neutrality in the design. So even in your conceptual stages, you can start looking at the carbon footprint of your project that you develop. That's a quick definition of what Reload Studio is. These are concepts that I kind of like dug up and useful in understanding how to use Reload Studio within a workflow. Starting at the very top it does work with Revit. So you start with your building information model, and coupled with that is simulation, and in between that is frictionless, meaning that it's very easy for your BIM model to get through to simulation without a couple of presses of the button. It's actually kind of easy. It's almost too easy, it seems. And because you've got it in the cloud, it creates flexibility. So once you create your simulation, you can access it in the cloud and do changes in the cloud file to take a look at the results. And we also have the flexibility of changing your BIM model from Revit and then running another analysis to see what design options you have. So you can actually look at it in two different ways. You can either change it in the cloud, look at the changes that you've made, or change the model itself and see what happens. So whichever workflow seems to be easier, it gives you the capacity to do so. Since it's being done in the cloud, as we mentioned, it takes the power of having a large computer at your desk to run these calculations. It takes it up in the cloud. You're free to work on other things on Revit, and then review the report as it comes down. And then it also allows collaboration. So once you have it in the cloud, the file is there, you can have other team members review it, take a look at it, make changes, make design options to it. So it doesn't limit it to just yourself, but it makes sharing the model a lot easier. So here in this chart, it's the way I kind of look at this is you have low detail to high detail. So you're going from like conception up to Revit, and at the very early stages, you can start taking a look at climate analysis, things that that you normally would do longhand, you can easily do with an application like Format. And then moving on, rest in peace, I'm sorry, but you can start looking at lighting, spatial areas, and then finally, once you get into more detail, you can start looking at energy data. Obviously, with a conceptual model, you will get these kind of readings, but the more detail you get, the better the results you have in the energy model. So from here, the way I look at it is you get a snapshot of a benchmark, early benchmark, and as you move towards your details, you have a guiding path to see where the changes are occurring as you start developing your designs. This is a typical workflow when you're working with the energy analysis workflow. First, you start creating your model. So here you've got your conceptual model, and then your Revit BIM model, and then here is your energy analysis model. The energy analysis model can be created from your BIM model. It doesn't really, what I found is it doesn't really like to take the actual architectural components of that. It's a lot easier to create the EAM or the energy and analytical model from a conceptual basis. Because what the energy analysis model is more of a stick snapshot of what the building is architecturally. So when you run the analysis through an actual architectural BIM model to try to extract an energy analytical model from it, you might run into some error, or it might not even do it at all. Charles, can you say
Well, yes, there's two parts to the BIM model. The first part is you can go into the BIM model, you can just say, all right, for the whole entire building, my roof is this, white, and my exterior wall is brick, the glazing is this. Run the analysis off the analytical model. But if you run the analysis off the BIM model, you have to go inside the BIM model. You have to fix all the thermal masses inside of the BIM model. So you have to go in, you have to apply the thermal mass to the block, to the brick, to the airspace, to the insulation, to the roof insulation, to the floor insulation. You have to put all this data into the model, and then you can run and use your analysis from the BIM model. And it will give you an even better performance from that analytical. But one of the big tricks to it is when you get to the windows you have to actually model double, single, triple pane glass. And you read. So it can read that it's triple, single, or so it depends on how much detail you put into the model to get a better performance out of it.
Yeah, if you take a default setting, if you just take a conceptual model, run it through Visual Studio, and just accept the model as is, it will use the default hash rate configuration. So whatever the minimal requirements are for hash rate, that's what's going to be used. So as you move away from that conceptually and start looking into thermal properties of the material of the building, then you can switch over. But as Charles mentioned, if you start doing it, you can't just do it spotting. You have to do the whole thing. And also take a look at how the connections are done. There is a flux variable that you can use for openings that it will fix. But if you've got like a gaping hole that has no thermal properties of it and you missed it, it will look at that as an opening, and then your model will show an erratic effect.
So besides understanding what you know about heat and cooling, we got to pick the system. You got to put all that information to the model.
Yeah. In fact, we're going to hit on that right here. It's like once you get your model done, then you've got to go in and start doing your settings. And this is the diligent work that we're talking about. It's already once you start out a conceptual model, you can do location and time data, and then start doing the programming with building space and height data easily, going into something from a Foreman to the conceptual mass model in Revit. But then as you start moving down, you don't want to take a default HVAC system. That's when we start going into the systems and operation. We'll get into that with the sample run. And you also want to take a look at how the building is being used. 24/7, they don't open during the day, and it's closed at night, those things. And then finally, once you start looking at moving from a conceptual mass model to looking at the components of the architectural model, then you have to start going into material data.
The only thing I would add, I would say that when you start the model, one of the first things that you have to do is get the location. Find the weather map for the closest location, pick one. And then your true north has to be the correct orientation. And you can also set your plan on go back to where it used to be, but Detroit like on a 30-degree grid, you might want to have true north at the 30-degree grid. So when you run the analysis, that's the example. You go ahead.
True. It's very easy to just start drawing your building with using the coordinates of Revit, but there is a tool in there to put in actual building. That's almost like something that we can discuss in another lecture, but we're going to try to get into that technical information. And then once you get all that information, and then you start getting into the simulation. Again, it's like the more detailed information you have in the settings, the better your simulation will go. And you'll get your energy use per cost, your potential energy savings as analysis. You'll get that as a report, and that's when you get the feedback and start to report it. And then once it's up there, you can start reviewing it and start going through these cycles to make it more efficient for building performance. But also you have the ability to export your model. If you're not content with using Greenbuild Studio, you can export it up to DO2 because it is a GDXML file and also on Energy Plus. And I know early on I started using these, and these are more cryptic way of sending it through because these are basically text files that you have to send up that has to be formatted in a certain way for these engines to analyze it properly. And then you can get back and then start doing analysis in the model and then cyclical process going through this to attain a high performance building.
When you run an analysis, does it ever motivate changes in the original Revit model? Or is that only, like, it gives you reports as feedback and then you have to make those changes?
It's going to be up to you, user, because it's just a report that's giving back analysis from that mathematical model. The way we look at it is, here's our first one, here's our benchmark. And what I'll show you in our example is one thing that we do look at is the 2030 challenge, or the 2030 challenge architecturally. And that looks heavily into the Energy Star energy use intensity. So once we benchmark the energy use intensity for that location of the building, we want to meet that as a 2030 challenge architecture firm. So we look at that first, we get that benchmark, and then we start running this analysis from the conceptual model. It's like, is the massive correct? That's number one. It's like, are we being too extravagant of open glazing, or we're just throwing that out the window? You know, we want to be real about where that lies. So that's where you start out looking. So is it the shade? You can start doing sun shading analysis. You can look at orientation of the building with other things. And there's an endless array of these options that you can go through. And we'll kind of like touch base on that as we run a sample model. Because that's something that we did talk about when we started looking at conceptual models early on and how the building was going to go. But then as we ran through, we started seeing that this is not really meeting the energy that we're looking at, or this is what the client maybe might be interested in.
And then do you get lead reports?
Yeah, there is actually a tab for that.
Okay.
It's not all of it, but it's for energy performance. There's like tab for that. So in this this slide, it shows you the different ways to get a model out. So first, we talk about conceptual massing, which is probably the easier one to get through to get an easy model going out of it. But we use that early on to get a benchmark for massing, and then and just maybe some glazing if you have to. But then as you get into more complex, you want to use like room and space elements to start generating your energy analytical model. And then typically, as I said, the fastest and most reliable real architectural Revit models, you want to do building elements, then energy analytical model based on information that you fed into the model itself, and then that will get you your energy analysis. But this is further along down the line as compared to conceptual massing. And then where energy analysis tends to lie in our work flows is we have the design model, conceptual model going through. We do a design model, and we get our energy report going in, and then a cost report goes in for owner review, and then it goes into cost estimating, and it goes into the design model. Energy analysis stays in within this loop, looking to satisfy the owner as well as the cost or the budget for the building. And then for the demonstration, I'm just going to do a basic run. Hopefully, we can do a really quick one to do a basic navigation of the ribbon, icons, energy settings, minimum requirements, how to do location and climate data, the building type, energy simulation. If it doesn't run, it runs a little bit long. I've got 2 reports that I've already done up that we take a look at, and then how to do the results and compare, do potential energy savings, how to do for that. Project Salon is in beta right now. It's basically dashboards to let you customize the charts and reports that are coming back to you, so you can tailor it to your client. And then doing an export to XML and go to et cetera. And that comes with Greenbuild Studio that's web-based. So with that said, let's like jump into Revit and take a look how it goes. So this is like a simple concept model of a project that we're taking a look at. Very simple. I didn't want to make it too complex because it wouldn't run, but where you'll find Greenville Studio is under Analyze. You see these toolbars pop up, but you have to be signed in. So this is Autodesk 360 sign in. So you see I'm already signed in, and that allows these tools to pop up for you to use. So there's two different modes over here, starting from the left-hand side. The use conceptual mass mode, and then this is the use building element mode. This is where we talk about where if you are doing a more detailed analysis of the building and the building is further on down the line, you're going to have to do thermal properties to the building elements, which does not come shipped with some of the materials that come with Revit. You have to go through a process, right, Charles? It's almost like a sidestep subcategory in the material properties to put in a thermal property for that.
And you need the ASHRAE book that tells you what the thermal property is for masonry, concrete, drywall, limestone. you have this in that book, and you have to put all the values in the material sections inside of it.
Yeah, we try to do one real quick one, like do a wall. So if I bring up a wall under edit type.
And most of the time when you do these analysis, the model has to be 100% correct.
Yeah.
There's no mistakes in the model. It has to be 100%. No mistakes. The slightest hole is going to throw the whole analysis.
So here it says, as you can see, it's by category. Or if you go by category, just use the default. Like here, you do like chipboard, and then you go to plus up here. This is how you do your thermal properties. So you would add it on here, and then this will add on thermal property to that element. So if you did go that route, you have to think of every element that you popped in there, every type. You've got to go in and do that. Because by default, there's no thermal properties in a majority of the material unless you're from a manufacturer or a good detailer or a good BIM specialist that popped it in there. So conceptually what I'm doing is I'm just kind of cheating.
Now, with me as being a consulting engineer to you guys, would my model, which references or links to your model, automatically inherit any of those material properties that you populated in your architectural?
No, unless you did it up in the cloud, and then you click on update model, then it will send information back to update the model to the architect. But if you have a separate reference file where you update items there, it's going to stay within that federal that standalone model that's being referenced in.
See, so we'd almost be better off creating, binding all these into one, into an energy analysis model that gets uploaded.
Yeah.
So that so that in the hypothetical project that you don't actually do this on together right now, but in theory could, right? Like take your architectural model and ours save it at a certain spot on the network, and then bind them together. And now we have all of the material properties that you assign to your walls and doors and windows, and what we've done with our mechanical and electrical systems and lighting systems. And then we've got a fully designed model with material properties that can have an energy analysis on it, right? But then we've just lost the ability to have it updated.
Yeah, that makes it seem a lot more complex than it actually has to be.
More than likely, the architect has most problems for the energy, which is the walls, doors. For the ductwork, you put properties in it. You guys just have like a checklist. So the split system, the heat running,
Yeah.
and then you just run it from there. And then the lighting is its own separate little button you click and it generates lighting. So the architect's probably more likely to.
But if they're testing, various efficiencies of the same system, right? They want, whether or not they want to go to a higher efficiency.
Yeah, I'll tell you, people run on their repair system. You got all the ductwork running to the fans and everything, you run the bulbs, and it generates all the dirty in. So the architects really wouldn't care about that, of what you guys are doing.
Well, it's teamwork, right? I mean, they might, because, like, if we went with us didn't have any ductwork, it was all the piping on the system, then they could get a lot more sealing space, or they could run through, eliminate a lot of the plumbing space.
Your space, when you put your space in, that does most of your analysis. You need space. The architect for the rooms, you guys need spaces, so when that ceiling comes down, your space comes down, and it calculates your value. Just multiplies all your other calculations. And then your architectural model can have the mass properties already involved. So when you run your analysis, it'll read the architectural model. But like the architect, you want the architects to head because they have the core and shed, so to speak. And then your space is just going to create your values and your calculations. And their rooms are going to do their calculations. And models can still stay separate, so to speak, but you won't be able to do their energy analysis as well. What they really look at is the majority, they don't know about the values and stuff like that. But
Yeah. If you're looking at like mechanical versus mechanical zones versus the architectural model for performance, you can almost see them as two separate ones. So they don't necessarily have to be tied together. Because in general, what we're looking at as architects is the performance of the outside skin and the shape of the building and anything that we can do in terms of the material selection. But in terms of how the HVAC performance can go, that's like something that's totally separate from what we're doing. So we talk about location. That's very important for us. You apply this here under manage. So if you click on location, I've already located this building. And then I also have like a weather station already picked out. So there's the building. This is confidential information, by the way, so we don't share this. And then we have a site. So give it a minute, it'll probably pop up where the little pin is at. But it's as simple as dragging the pin so you can zoom in on the area. Oops. I move that. Hold that in. And then the coordinates, and then also the position. So this has already been on this one. If you go to the top, we've already located the building, so we see the actual location of the building and how it's being located on the site. For the information, internal project information. Under energy settings, energy analysis, this is what we start doing the default information for the building itself. So the building type is sports arena. The location we have, we grabbed it from the location up here. First level is on the ground level. Export categories, rooms. Simple shading. We are looking at shading on this building, so that's where a lot of our emphasis is for this model. And you can just see we just took out the defaults going in because we want to see what the benchmarking is. HVAC system, we're using central PV, hot water heater and chiller, and then outdoor air information. We just took the environment that's there.
Is that silver spacing the kind of the tolerance you're talking about if you have there?
That's exactly right. Yeah.
So that's telling us to how accurate model.
Yeah, our model can have as much as it's capable, where rather than find something like that and just hold it out. You can make it bigger, depending on how much messiness there is in the building. But on some of our models, we are taking conceptual masses where the designers are just throwing things down as a mass, and we don't know how clean they are. But if we're just looking at a quick snapshot of, let's take this building, what kind of energy will it actually take if we built it in that way? What is that benchmark? And those are the quick questions that we have when we're doing a conceptual model. Once we start going down the line, we'll go, okay, well, we know that we can do that. We'll this direction, then we're going to start detailing it out even further. But what we know, once we start on a path where we start a benchmark, and we do a simple design change, then we can see where the two different energies are, the EUI overall, the gross measuring stick to what we're looking at. Then you can see whether it's a good move or a bad move in terms of the performance of the building.
If you go to the Department of Energy, they have a matrix of like buildings certain size with EUI. And normally when you run your analysis, you get the benchmark EUI, you're supposed to match it to another building that's a Department of Energy site and say, okay, well, I got an office building 20,000 square feet. The government says that the EUI is 19. I run mine is 17. And it lets me know what I'm stacked up against what the government says is average. So if I go 16, 15, 14, whatever, then I'm going to overperform and how performs here.
And what Charles was basically describing is the Energy Star program. When you go in and do a project with Energy Star, it can be a fictitious project or it can be a real project. So anonymity is basically number one in that site. You can pick a site and then it'll give you the EUI of the building type once you describe it, how many floors, what's going to be used for, and that's going to be the benchmark for here on 30. It'll give you that site. And now I've actually got to print out this one that we did once we get through here. So let me just quickly get through here. Click on the run the energy analysis. So we're going to use the conceptual model, not the element model. And for the energy setting, we've already talked about that. That's this guy here. And the energy model, I'm using conceptual. I'm just going to run the energy simulation. So it's that easy. So once it gets going, I'm going to use that as the analysis run number 3. Actually, I'm going to change that because I've already done that 1 and 2. I'm going to do a change. So what we've done on this model is we've got a couple of resoleil analysis or options we were looking at. I did the resoleil active 4 just recently, so let me do resoleil active 3 just as a big comparison. We make that primary. That's why to get it up there. So that's going to be the resoleil around the building, and then I'll close that. So that's become the model now to do the analysis. And this is something that you can't really do up in the cloud, where you're actually doing an architectural exterior resoleil. You can do a general one where it says, oh, well, around the building we'll do a perimeter of this type of style. But on this one we have a different texturing of an orientation of the resoleil all the way around. So using the solar analysis, we can actually get a better readout on this type of architectural statement versus taking the general that we can run in the cloud. So it's maybe more.
Can you zoom in?
Yeah. So you can see here the blades are different spacing and they're different depths all the way around. And then that's going to do a quick run simulation. And then once you hit run energy simulation, it'll give you this pop-up. It'll ask for the run name, and then it'll ask you for the project name. If you haven't started a project directory for this for the model yet, it'll say create new. But since I've already been working on this one, it's already been started up in the cloud, so I can click continue. So I know that it's loading, so it's starting here. And then over here on this, up in the cloud, if I open up my BIM Building Studio, log back in and refresh, go to the other facility. So let's go to starting with those. So right there it is. There's the file working right now. And then on the flip side, if you want to stay on your desktop and not go to the internet at all, you can get results and compare. And that run is number 3 right there. So you can see it's working. So you can keep these to the side, and you're free to work on anything else around it. So now we just have to wait until it comes back down again, and then we can see the analysis on there. Let me show you this real quick. We talked about the finding what EUI is. What is that? The energy use intensity. So this is the Energy Star portfolio manager that we got for this project. As you know, with energy, the Energy Star, it's very simple to pump in simple information about your building, not complex at all. but it does pick up this very important graph that we want to use to benchmark the building. And what this is, as Charles mentioned, it's an aggregate of all the buildings of your size and your building use averaged out for that location. And that sets the benchmark of Architecture 2030 as the status quo at that location. If you were to build at that building, we expect it to be this standard. If you go below that, you're below standard. But because we're talking about Architecture 2030, we're looking at an improvement over the energy. So here's the median property here, and then this is the number that we're looking at achieving for our building. So you can see right here, the design target we're setting up is set for Architecture 2030. So you can see the difference. Here's the median property.
That's what your client wants to see, more than half.
Yeah, definitely more than half. So what we're looking for, though, is like there's a source EUI and there's also site EUI. When you want site EUI, what that means is that it's site-specific energy being used. So median property is 42.5, and then the design target, based on Architecture 2030, is 10.6. Pretty steep. How many buildings have met that criteria? Not many. I would probably say less than 60% have met that have signed on as Architecture 2030 challenges. So realistically, that's a great goal to achieve, but the results that we've seen so far, not a lot of buildings that have tried to achieve it get that goal. Because whether the budget doesn't agree with it or their client is comfortable getting to that level, we don't know, but I know that from the papers that I've been reviewing, to meet the Architecture 2030, it is possible to do, but it is it's a bit difficult because not a lot of architecture actually meet that goal. So
let's say it's in the 10th percentile, or the top 10%, the 10.5%.
For Architecture 2030,
Yeah. So
I wouldn't know.
The units over here.
Yeah, this is
Oh, I see.
this metric right here is the energy use intensity. So what it does is it takes the area that you're using as a built area, and it's the kilo BTU square foot of that of the built area.
Yeah.
So once you know that, that becomes very important because then you start looking at your results. So if we pick up the results and we look at that run, so this is the benchmark run that I just did earlier. So this is without the brise-soleil, this is with the four-sided brise-soleil, and this is with 3. So if we look at the first one, here's your energy use intensity here. Total EUI, 43 kilo BTU square foot per year. We're at median. So we've got a lot of homework to do to meet that EUI as proposed by Architecture 2030.
Sometimes an engineer can come into this because they have options that you said power density, that show 1.75. Yeah. You know, you can say, well, let's try 0.75. We use 0.75 when we run the analysis. You know, say, okay, the energy went down, this much, the cost went down, this much, this. You're looking at say, well, the cost went down.
Yeah, exactly. Oh, you want to
So what this gives you is it gives you a really good benchmark and a relationship to real world numbers. Something that people usually when they go, oh, well, energy model, we can run an energy model. What does that really mean? What do you get out of it? What we're getting out of it is a gross benchmark. So for this model that we're looking at, which is just a box that we have out in the middle space, oriented properly, using ASHRAE default settings, and a little bit of data, we know that it's going to meet at least minimum requirements for ASHRAE. We can do better, obviously. But for this one, that's what you get for that minimum amount. Now, if we go into putting in a four-sided brise-soleil, yeah, we do a little bit better. We're actually down to 40 BTU for EUI. So we save 3 EUI units for that one. And then if we go and just do 3 sides of it, not that much better. We can take one side out and we're still that good.
All we remember is benchmark. Benchmark. a college professor, probably was a few months ago, his college professor said 100% of all energy models are wrong. Right. That's why we kind of make sure that we say it's a benchmark. It's not.
Exactly.
That's why, the new league certification plan system is based on like a 3-year return for measurement. So,
Yeah, I mean, on these models, this number here isn't really impressive to us, other than the fact that how closely it relates to the EUI for the Energy Star and then the Architecture 2030. What we're really looking at is with that assemblage around the building, we can save 3 EUI off the building. That delta is more important to us than that actual benchmark number, because this could change out of it. But what we're interested in is that assemblage to argue whether it's beneficial or not beneficial. How much improvement do we get out of that as an architectural statement, as an energy improvement solution to the building?
when you take into account the context around the building, we said it was building in middle space, what happens if there's a space barrier to the south bit.
Yeah, you can
Take
actually.
into account that.
Yeah, you can actually take account of that. You just have to model it in the environment, and it just becomes part of it. It's a shadow building, is what they call it. You can view a shadow building in the massing, and then it would just continue on with you when you click it on and off in the model. Once you start developing it down the road, so your model to get more detail. I'd probably say keep the model, the conceptual model mass in the file, so that you have the geometry with you, because on some of the files where we started working on this and we got more detail, we actually deleted the conceptual model away, and that forced us into either one going in doing an element mode and pumping in all those numbers for each one of the elements, or recreating the master model behind this, so we have a faster readout for the energy model.
I forgot the name of it. There's a add-in that does the thermal mass of a mass. So you have like buildings surrounding it, and you run the thermal simulator, it will show like, okay, this is purple, which means it's hot inside, red over here, yellow over here. You got buildings up too, it will show you where it's cool, where it's hot on this side, cool on that side.
That was pretty sorry.
It was sorry, not just written down, but it's an add-in. It's a free add-in. It doesn't cost anything.
Yeah.
But it only works when you have a conceptual model, but it won't work with the regular model.
Yeah, and the same thing goes with it's basically the solar analysis. Yeah, the solar analysis toolkit, and then with that was also the balloon simulation, so you can do the CFD. And those are like the big tools that we were using. Sorry, larger projects. You can drop in a stadium wall to see where the wind would go and all that. The environment around it. So any questions with this one? So we move on with something a little more interesting, a little more flip. We're going to talk about dynamo and how to make this thing work. We might cover it. So I attended Facades Plus last year. I don't know if anybody heard about that. It's a building enclosure seminar conference out in Dallas. And I got to meet some of the guys that were working on Revit and Dynamo specifically. And they were showing us a couple of neat tricks on how to use Dynamo to automate the energy analysis, especially if you're doing a building that has dynamic forms of it, or you're doing dynamic forms of it using computational modeling. So let me open up my next file here. So here's a building, and this is tied in with one of my add-ins, treat up my Dynamo. How many of you using Dynamo? Anybody like using Dynamo? I know you do.
It's not the easiest of programs.
So what Dynamo is a visual scripting tool for Revit. It also works with other programs. So it's got a broad spectrum of what it can be used for to automate things. You just have to start getting into it. And this is a free open source system that links in with Revit. So you can go in and you can do a multitude of things depending on what mode you want to be working in. But what I wanted to show you today is how to automate a process of building form with energy analysis tied in with it. So this is my workflow here. Unfortunately, because of the upgrade, they just recently upgraded to 8.0 for Dynamo, and then they upgraded the toolkit that I'm using, which is energy analysis for Dynamo, and it broke the link that I was using at the very, very end. But that's okay. I can explain to you what I'm doing in the workflow here. Looks like spaghetti, but you kind of get the gist of it. I just want to get everybody a feel for what's going on the bleeding edge of building analysis and using computational modeling to develop a high-performance building, especially through the form and environmental analysis. And there's huge flexibility in this, so this is just kind of a sampling of what I've seen. So here, if I just do a quick run, it creates this little box back here. Zoom in, so we can see what I'm doing here. Go back to the node. So what this guy is actually that building right there.
That's kind of the change that started to happen in Dynamo. You can kind of start to see the shapes, and then you go to icon visible.
Yeah, they cleaned up this a lot. A lot of it was very cryptic in terms of it was very DOS-like. Far from the Grasshopper. If anybody's using Grasshopper, there's icon-based. You can find tons of tools and nodes. And we've got, I work with some of the guys here that are using Grasshopper, and I've got a couple of them to take a look at Dynamo. I'm the sole Dynamo guy trying to learn Grasshopper, and this at the same time so that I can talk with them both. So here, we start looking at how this is programmed. This box right here is controlled by these sliders, it's programming. And here, I've just got a couple sliders to control the ground height, the typical floor height, and then the number of floors of the building. And that plugs into a code block. Code block is like a generic equation block that you can program to do anything. Here what it does is it creates a list of the ground, number of floors, and the type. And to show you that there's a link, I can actually grab a floor slider, move it up to like 6 or something. And I'll show you that over here, that I'll go run, and we'll see that changed. So I can dynamically control the building from within Dynamo. What does that mean? It's like, well, you still have to go to the Dynamo to change it. Well, I can take these number sliders and connect it to another node. So if I said the movement of the sun changes the height of the building or the mass of the building around it. So I can have more than one, and I can say, well, give me the size of this building based on 80% of this, and then it'll do it automatically. And that's when you start getting into computational modeling and then environmental effects and the form of the building. So this is more of a simplistic look at it, but it gives you the lookout of what's potentially possible to do that. So if I go to breakdown of like where the number of floors are, it just gives me a list, so I can name my floors. That's all that this branch does. And then it gives me the name and it ties it to an elevation. It's back here. Once I get this list, it gives me basically the floor heights or the elevations. Then I'll tie that with 0 for the first floor, and then it'll give me a list, and then that'll give me the total height. Once I do the equation to here, and then from here, it gives me the level. So it gives me the name and then the elevation. So here, if I zoom in for that one. Okay, so it'll give me the name. So this is like S1. You can see that from back here. I added S plus S for the floor. So then we have S1, S2, S3. And then finally the roof. Over here we have S1 through S6, and then the roof, and then the elevations that are there. Why is that important? Well, it's important so that we can generate the energy model. So the way I'm generating the energy model is I'm creating this box. So I'm calling from within Revit, I'm calling a building family called building mass, basically a conceptual mass model. Dragging it in and giving it some parameters, or at least answering the parameters that it needs. So I'm giving it a length, a width, and a height, which is controlled from these sliders back here, and also controlling some other things too along the way. So back here, just kind of like organically spaced out. But here for the building length, I tied up here for a rectangle. This here, this is the creation of the mass. This is kind of the definition of the building as we move along. This develops the bottom curve, meaning the rectangle for the base. And so if I click on it, it will highlight that. And then what I do with that is I loft it up. So I do a list create, and then I do a surface loft, meaning that it pulls it up to the height, and then you get your box there. And then from the building, this actually gives you the definition of the element that you're seeing back here rather than it's tied into it. That guy right there. And the reason why it's all split up like that in zones and for the windows is I'm using Dynamo to fill in all of my empty spaces for energy settings. So on this one, for this particular example, I'm using a slider to control the glazing percentage, and then the shade depth for the overhangs, and then the light permanence, or the skylight percentage up on the ceiling, up on the roof, sorry. And then I'm dragging the rest of it as default off of the model. And then because this is open, this looks like it's ending nowhere, but it actually is pumping it back into the model. And it sets up this setup.
The levels that it creates, it's not creating levels in Revit, is it?
Yeah, it is.
It is?
Yeah.
So it tabs together, adjust.
Exactly. So if I go over here and I go into these elevations, you'll see that these elevations match. S1, S2, S3, S5, and then the roof. I mean, it even took the roof with lowercase, sorry. And one thing to understand with like Revit or with Dynamo is that the model is in place. It's not. It's a different paradigm than Grasshopper, where in Grasshopper, as you move along the line of your workflow, you can actually branch off from there, and then wherever you branch off, you're taking that snapshot of the model. So you have many different models represented in the workflow for Grasshopper. That's not the case for Dynamo. Once you create a workflow here, the model is consistent throughout. So if there's a node that ends out here, like levels, if there's a level back here, I grab the level and I pulled it all the way to the front, it's the same level output as you have out here. Kind of weird because I was looking at it, it's like, why is it giving me that same reading? I haven't created those levels yet. It's like, well, there's a singularity to it. There's only one existing model. So however you create these workflows, you can look at these as being adjectives to the noun. There's only one noun. All of these are adjectives, and they only go to one model. So if you have a node that creates a levels breakout, and like back here, the level will be the same here as it is over here. So once we get to that point, to create the file, I just have to point to what file to write to. That's how the file path goes. And you can do browse. It's a typical browser window. You tell it where it goes. You want to do a sample file. So here it's going to test XML. I'm not going to put anything in there because it already knows. And we're talking about preparing the energy model, and I'm doing it as a mass family instance based on the geometry of the building of the family mass that I've got back here. And then the level will break it up so that it gives it the levels going up. And then automatically it will create its own IDs. And then also the mass family here. But what I'm running out of is when I get to this point, and then I click, and then I connect these two guys like that network. If I run this simulation, there's a break, and this one doesn't work. But what this will do is it will actually pump out the report, GBXML file, to this file, and then alternately, I can also run the analysis using the mass family instance. I tried this last time, but it wouldn't run. I just don't understand why it broke. So that's something that I have to take a look at. I do know that the file path is working, so it could be a readout here. That's what the watch is. If anybody sees these little guys here, I kind of pop these in here and there to make sure that I'm getting a data readout. From the GB XML file path, we support it out from here. I'm going up here. So what these branches do is to set it up so that it will grab that GB XML file that I just wrote, take it, and then send it up to the cloud and do a benchmark iteration. Since I've already created the project name from here, so it's like project titles, this is actually looking up into the cloud. And I know it's reading it because it's giving me this readout. These are the projects that I'm working on. This is the file that I want, 0 here. That's the project ID that I'm identifying here. And then I'm telling the Boolean, well, for the Boolean, I can either do execute parametric runs. What the parametric runs are talking about is the parallel runs to look for energy efficiency in the cloud. If you don't want to have a longer runtime, you want to just do a quick run to see where the energy analysis, especially if you're just looking for one piece of data, you would click that on, and that's what this Boolean node is for. I can turn it on or off. I usually just, if I need to turn it on, then I just hit true. But if I just don't want to bother with it, I just turn it off. That's what that means. And then from here, this node will send it out to the cloud, but every time I've been using it because of the update, it broke. And the reason why I know it broke is because it's not lighting up. There's something about it that it's not working. It did work previously in 7.5, but because of the update, both for Dynamo as well as the toolkit that I'm using, the energy analysis for Dynamo, there's something that seems to be broken with it. But the way you know that it's happening is I did a run over the weekend, and it did work on it. So I'll pull this guy over here. One of my projects. So here's the energy start analysis that I've been working on since the past weekend here. And it did run it. So I know that it worked when I was running 7.5, but once I got to like 8.0 and the new downloaded, it didn't work. But it works the same way. The only challenge is that if you use Dynamo, you're only going to get the report. So the report looks like this. I'm bringing one up. With the GB XML file looks like and what the which export will look like. Because you don't get the dynamic reporting that you would have if you were in Revit and you had the reports come back at you, where you can have these charts side by side. You don't get that with running with Dynamo. Dynamo is more, I guess, detail-oriented, numerically more abstract. If you're looking for a piece of information, you basically tell it to look at this piece of information, analyze it, give it a maximum and a minimum. If it doesn't meet those requirements, to do it again. So for a workflow like this, you can easily take this type of visual programming and automate it. So you can take that model, basically that model is look at, and start rotating. And as you're rotating it, send it a report. It's like, hey, what's it telling me? I don't want to see that line. It's like, is it doing better? Is it doing worse? And then once you get to that point where it's like, hey, this is the point where it's doing the best that it possibly can, then you can save it at that point. You can say, without a doubt, from 1,000 iterations going 360 degrees, this is probably the best solution you have for that, whatever it is criteria that you're looking for. So this is kind of a quick snippet of what it would look like to automate that and how to loop in energy analysis with Dynamo.
You said you actually have to physically change the rotation of it and then set it up with cloud each time.
Yeah.
Like through this. So
Yeah.
a way to just automate it, give you a curve of what the change would be in energy and whatnot.
Yeah.
These are Dynamo iterations. Right?
Yeah.
It's going until it finds them.
Yeah, Dynamo would be doing the movement. So what you would do is you would just do you would add another branch on here. So for the location point, so up here where you have the vector x-axis and the vector y-axis, that gives you the origin point, so you know where the location point is. And then from the placement of that, the building mass family, it's got a parameter in it called angle, and then you can start rotating that angle. So from within Revit, you can just write a branch in that says, for every iteration that it counts, and then you can use the run ID. So you use a counter for the run ID, all the way up here. The run IDs, use run IDs as your counter. As your counter moves, and then you're looking at that piece of data, energy efficiency, you can look at EUI, where it spikes the most, you're looking for the most gain out of it. You can either get a full readout or just say a maximum and a minimum. So you'll throw out data sets. Then you're starting to look at, computational model, where you're just instead of building a building like this, you can just do this really quickly and then have this thing run over the weekend. And then, look at hundreds, thousands of iterations of what you can do. So kind of like a small snapshot. Let me go in here and open up one of those GBXML files. So you guys take a look at that. So this is what a GBXML file looks like.
Some of those GBXML files, you can use them with like eQuest, Energy Plus, we'll read those files. I know sometimes engineers, they use the eQuest and Energy Plus free, a little more free software that you use GBXML, we'll read it. So you check it out. When you go to Studio, you can go right to Energy Plus. And I believe Energy Plus is integrated from up there.
Nice.
They're with cloud-based software. So they'll work back and forth with each other.
Yeah, there's interoperability there. So if you're not satisfied or you need a separate confirmation of the energy model, you can take it to those sites and have your energy confirmation put there.
Well, it's like years ago, you would make the payment model, go to the GBXML and go Ecotech. And then it would bring the model in with all the rooms, and the volumes and stuff. It's easier to run your analysis in Ecotech.
See, way back, I was doing it on residential, but I was using SketchUp as with the SketchUp plugin. But even then, it was terribly painful to get it ordered, to get everything clean and concise, to get it into a format that would export out as a clean GBXML file, and go up without any problem and come back down. Because what happens is you get an error, but you don't know exactly what the error is, so you have to go in line by line and look at where that occurred.
Yeah. Now, Wall has 15 trains.
Yeah, sure.
So this is what comes out of the Dynamo report.
Yeah, this is the GBXML file. If you do this is for Dynamo. No, this one came out of Dynamo. The Dynamo uses the same engine that you're using within Revit. What Dynamo allows you to do is to actually link into that automate the process. So if you're looking at something that you have to take a look at Dynamo as like a calculator, as a problem-solving tool. It won't design for you. It won't think for you. But if you're looking at a something that is mathematically calculatable and definable, and you want to zero in on that and find it, or you can look at different scenarios with it. So you can take a look at it two different ways. You can kind of take a look at it in a solution-based paradigm here in the office, as opposed to something that could be like formally based. Because I can take Dynamo and create these little wavy things and slap it on a web model all day long, but it doesn't give me any performance enhancement. So what we're looking at is solar and wind for the conceptual asset, and then use those as the drivers for the Dynamo engine.
What you can't do with it,
Yeah, it's fascinating how Dynamo creates a different environment for you to work in. It really loosens up what Revit can do once you get into Dynamo, but it doesn't really have to be Dynamo, because I've also found some really interesting ways of generating families, especially the new family types that come out. I don't know if you've had that same opportunity, Charles, with the adaptive components and writing with that. And I know that you can move it in with Dynamo, but also with just like generating some forms that the designer can come out with nowadays.
Yeah, one of the things that I don't use Dynamo that much. I use it when I can't model something really. I have to do it forward. It's a Coliseum forward. It can slowly do it. I couldn't revolve it. I couldn't make it flat. I couldn't bend it. So I ended up I had to make it flat. I had to add points around the shape. And I had to send the points to Dynamo. And tell Dynamo the points. And that's how I built the shape. But doing it really, I couldn't do it. I just wanted them to do it. Kept doing it here and stuff like that. So I had to use Dynamo. It was a little bit around it.
Yeah, because we're actually working with the other layers. We generate geometry in Dynamo, then pull it in, because that gives us some options of moving it. And with the ability to link it with environmental factors, we're looking at a whole new ballgame, like why forms are the way they are. So we can see things that we were never able to measure or calculate or even give shape to, because now we have all this visual calculator that we can look at, both in solar radiation, as you mentioned before, computational fluid dynamics for flow and shape of the building, and then also structure, some things that we haven't even gone to look at in terms of structure.
What Dynamo does with development, they'll take some splines, curve out, and model a face, and then Dynamo is going to just, if you don't like that face, you bring in another face, and you just put faces in. If you don't like it over here, you twist it over here.
So that's kind of like it for my presentation. Anybody have any questions for closeout? That clears mine. I think once you get into it, it gets to be fun because it's, I mean, the one thing that really got me the first time around, once I started creating the model, using sliders and seeing the geometric form change in the change analytically and then what the effects are in the model. And it's a direct link. And the one thing to remember is like in Dynamo, this is a sandbox, so this model is separate from the one in Revit. It's only going to become real until you push it in into the Revit world. And that's usually done by nodes. So here in the nodes, once I get it to here where I'm calling out the family, and I assign that family properties, then it pushes it out. This is not the actual thing. This is just what this is back here is just the extraction of this guy here, the rectangle. So this is just a rectangle, but from the rectangle, I gave definition to the building mass, and this is the guy that's out there. So you see, if I click on this, it's not this. That's just this guy back here. That's that, and then this, and then some of this. And if you don't want to do geometry derived in Dynamo, I also dropped this guy in here. So if you were working on something, say SketchUp or any other project that's a SAT file, or anything that's a three-dimensional file, you can actually pull it into Dynamo and use that as analysis. And then you can just string these together. So you can tell what the file is, connect the file to the path, and then geometries, and then that will pull it into the Dynamo world. Then you can start doing analysis on that. And do some really weird stuff with it. All right. Yes, sir.
Thank you very much. We got a couple books here for you guys for posting and presenting. So, Detroit, hopefully you don't have that already. I just wanted to do one quick thing. Go to the internet. This last time, AIA Detroit has just updated their website. So let's go to AIADetroit.com. And so if you go under committees, we do have the Technology and Architectural Practice Committee. I don't know if it hit. Try it again. That's nice. There you go. It's spinning. So this is our Technology and Architectural Practice. Under recorded programs, hopefully we'll have this up there in the next couple weeks. Technical resources, if you click on that, this is a list of different websites and plugins that I've pulled together the last few years. So if you have any websites that you guys have come across, I'd be happy to throw it up here. I don't think they put our email address, but our email address is aidetroittap@gmail.com. And if you have any suggestions for us, let us know. But hopefully this is a source that everyone can use in the community. So with that, thanks for coming. Our next meeting is going to be July 21st at HKS in Northville. And I think their presentation has something to do with similar parametric design, but from a planning standpoint. So kind of interested in that. I know they do a lot of healthcare planning. So if you can make it, that'd be great. It'll be 6 o'clock, and it's the HKS in Northville.
So July 21st.
July 21st. Okay. If you haven't signed in, please do so, and thank you, and have a great evening.
Thank you.
Yes.
Yeah. Well, you just did record. So there you go. Meeting screen.
Stop recording.